Here we have a city math problem. Okay, let's go with the question. If the graph of the function f of x equals to a to the x to the power negative b passes through the point c comma 9 and 2c comma 219, which of the following could be a value of b? Okay, here the graph of this function passes through these 2 points. Okay, when we have a graph for the functions like f of x, sometimes g of x, sometimes h of x, this f of x will represent the y coordinate in the xy plane. So we can replace this f of x by y. So then we get the given function will become y equals to a to the x to the power negative b. Okay, since the graph of this function passes through this point c comma 9, we can plug in this x coordinate c for x over here and y coordinate 9 for y over here. Then I'm getting 9 equals to a to the power of c negative b. Okay, now the same thing we can do for the other point because the graph of the given function passes to this point as well. So we can plug in this x coordinate 2c for x and 219 for y coordinate. Then I'm getting 219 equals to a to the power of 2c negative b. 219 equals to, here the exponent, two values are multiplied, 2 and c. Whenever two values are multiplied at the exponent, we can consider one of the values as exponent for the existing base. The other value can be taken as exponent for the whole stuff. Okay, here in these two values, 2 and c, I'm going to consider only this c as exponent for the existing base a. Then I'm getting a to the c power. Now I'm going to consider the other value 2 as an exponent for this complete stuff, that is a to the c power, the whole square. Okay, even when I simplify this one, it is equal to a to the power of 2c. That is, I can use the power of a power rule. So here we have base a and we have exponent c, and for this complete stuff I have exponent 2. Whenever we have two exponents like this, what we can do is we can multiply the two exponents, then we get a to the power of 2c. Okay, now we can write this negative b as it is. Okay, now let me assume a new variable for this a to the c, a to the power of c over here and a to the power of c over here. Let's say that k equals to a to the power of c. Then this equation will become 9 equals to k negative b, and this equation will become 219 equals to k square negative b. Okay, now I have to solve for k in the system of two equations we have over here. For that, what I'm going to do is I'm going to take the second equation as it is, that is 219 equals to k square negative b. Okay, now let me multiply both sides of the first equation over here by negative 1 and write the result over here. When I multiply this 9 by negative 1, I'm getting negative 9. When I multiply this k by negative 1, I'm getting negative k. When I multiply this negative b by negative 1, I'm getting positive b. Okay, here we can eliminate b, that is negative b, positive b will cancel out. When I combine 219 and negative 9, I'm getting 210. On the right side, we have k square and negative k. Now let me subtract 210 from both sides to get the quadratic equation in standard form. So this one will cancel. I'm getting 0 equals to k square negative k negative 210. Okay, now we can solve this quadratic equation using Desmos, or we can solve it by factoring. Okay, here I'm going to solve it by factoring. To solve the quadratic equation by factoring, we have to multiply the constant term by the coefficient of this k square. In this case, it's 1. When I multiply this negative 210, the constant, by this 1, I am getting negative 210. Now I have to get two factors over here, so that the product of two factors equals to negative 210 and the addition of two factors equals to the coefficient of k. In this case, it's negative 1. I think positive 14 and negative 15 will work. So by experience, I am getting these two factors. When I multiply positive 14 and negative 15, I am getting negative 210. When I add them, I am getting negative 1, which is the coefficient of k over here. Now, to get the first value of k in this quadratic equation, we have to change the sign of the first factor over here. It's positive 14. So when I change the sign, I'm getting negative 14. Now to get the second value of k, I have to change the sign of the second factor. It's already negative. When I change the sign, it will be positive. Okay, now I got two values for k. One is k equals to negative 14 and the other one is k equals to 15. Actually, I took this new variable k to make the solving process easier. The original stuff we have for k is a to the c power. So now we can replace the k over here and here by the original stuff a to the c power. Then I'm getting a to the power of c equals to negative 14, and here a to the power of c equals to 15. Okay, now our aim is to get the value of b. So to get the value of b, we have to plug in the value of a to the power of c, negative 14 and this 15. One of these two equations are over here. Okay, let me take the first equation. It will be easier for me to get the value of b if I use the first equation over here, because we just have a to the c power. But here we have a bigger number, and also we have a to the power of 2c and all. Okay, now let's consider the first equation to get the value of b. Okay, now in this first equation, what we have to do is we have to plug in the value for this a to the power of c. Let me use the first value of a to the power of c, that is negative 14. Then I'm getting 9 equals to negative 14 negative b. Okay, let me add 14 to both sides. When I add 14 to both sides, so negative 14, positive 14 will cancel. When I combine 9 and positive 14, I'm getting positive 23. On the right side, we get negative b. Here I got the value of negative b, that is 23. But our aim is to get the value of just b. B means positive b. Okay, to make this negative b as positive b, what we have to do is we have to multiply both sides of this equation by negative 1. Okay, when I multiply this 23 by negative 1, I am getting negative 23. On the right side, when I multiply this negative b by negative 1, I am just getting b. Okay, here I got the value of b. The value of b is a negative 23, but I don't find this negative 23 in any of the given answer choices. So now we can try the second value of a to the power of c, that is 15. Now we have to plug in this 15 for a to the power of c over here in this equation. Okay, now let me do this. That is 9 equals to 15 negative b. Okay, now let me subtract 15 from both sides. When I do so, this 15 negative 15 will cancel out. 9 negative 15 is negative 6 equals to negative b. Okay, again I got the value for negative b, that is negative 6. Now to make this negative b as positive b, I have to multiply both sides of this equation by negative 1. Okay, when I multiply this negative 6 by negative 1, I am getting positive 6. When I multiply this negative b by negative 1, I am getting positive b. Okay, here I got the value of b, that is the value of b is 6. And we find this 6 in answer choice A. So in the given answer choices, the value 6 in answer choice A could be a value of B. The correct answer choice for this question is A.